Good afternoon, everyone. My name is Flavian. This is Antonio. And we're here today to talk to you about how to write to Rust instead of C and hopefully get away with it. So first thing first, why are we here? All right. We both work for a company called Yelp. A bit of context, Yelp is a platform like website and mobile applications to help users find local businesses. Yep. Via reviews and like stars and comments and things like this. And Yelp is mostly a Python shop. So one use case you can imagine is a user going on the Yelp website or the Yelp application, hitting some code that is written in Python. This code needs to do data serialization. We use the Avro serialization format to do all serialization, for instance, having services talk to each other and things like this. And eventually magic happens and people get reviews and things like this. So a little bit more about Avro. Avro is a serialization format. You need schemas to serialize your data. So the schemas are defined as JSON structures. So if you have a record that you want to encode with like two fields, A and B, this is how it would look like. Avro is binary, so like unlike JSON, which is like text-based Avro, you just get bytes that you can send over the network or whatever. And it's serialization format, and serialization and deserialization is usually hard on the CPU. So like usually, if you use Python, which doesn't shine with CPU instances, CPU intensive tasks, you're gonna have some problems. So flashback in 2004 when Yelp was started, it was only Python. Now it's 2019, we got Docker, microservices, blockchain, whatever. And we have multiple languages like Python, of course, which is the main language, JVM-based languages, Go, and even some Rust. So you can imagine a new use case where you have some Yelp user that's going to hit some code that is written in Rust. This code is going to have to do data serialization, Avro, hopefully written in Rust, and then magic happens and people get their results back. So you can start to see the pattern happening of you have somebody using Yelp, depending on what service they're using, they're going to hit some Python, some Rust, some Golang, whatever. And each of those will need to do serialization to like communicate with each other. So you have a Python implementation of Avro, you have a Rust implementation of Avro, etc., etc. But why just stop there? Why couldn't we do Python services talk to like write Avro stuff using a Rust library? And so the benefit of that would be, well, of course, probably speed, but also the fact that you only have one implementation of Avro that you have to maintain, and all the languages will use that. So what will you hopefully bring home from this presentation? How to use Rust in code in Python packages. So it seems to be pretty much the theme of the day today. Why to do that and when you should do that? Some facts about Python, C, and Rust, and maybe some jokes.
Thanks. So just to get a feeling of the room, who is a Python developer? Okay, okay. Who is a C developer? Who is a C developer and doesn't want to admit it? Ah, here we go. Found it. All right, all right. So, well, first of all, if you're a Python developer, you know that when you write a Python application, everything is fine. It's easy. It works. And after a while, you have this feeling that your code is a bit sluggish. It's kind of slow, right? And you tried Rust, and you're like, oh, man, I wish I could just rewrite this whole thing in Rust. But your company is making money out of it, so you cannot. But still, how can we make this lag be a cheetah? How can we make the whole thing faster if you're writing a Python application? Well, I'll tell you the trick. 99% of the time, I'm making this number up, but it's mostly true, trust me. Scale up, scale out. We are on the cloud nowadays. If you're not, move. And so it's easy. Just, buy a beefier machine or add 200 machines more, and that's it. It's mostly a website, isn't it? Come on. So that's it. Really, that's the end. Okay, in the 1% of the cases where you cannot, because money, because you never know, you got to deploy your own server manually, you don't want to touch the switch. Try changing interpreter. And when I mean interpreter, I mean PyPy. What else? So PyPy is another open source interpreter for Python. It's much, much faster than CPython, which is the reference implementation maintained by the Python community. It optimizes Python code, but only Python code. So if you have any C extension or any C code compiled in your application, that goes low. Anyway, PyPy is great. It's almost a drop-in replacement. I mean, you can try drop-in. Maybe you'll find some bug, but most of the time works. And 99.9% of the times, you're done. Now, here I'm talking about the 0.01% of the times. You gotta bring out the big guns. And the big guns are C. So, as you may imagine, CPython is written in C. So, there is a way to basically write some C code and make Python execute it for you. This way is using C extensions. Now, just to get a feel of the room again, who among the Python/C developers ever wrote a C extension? Who liked it? Here we go. All right. So C extensions are a pain, and at Yelp, our philosophy is PDD, pain-driven development. So basically, after a while of writing C extensions, we say to ourselves, never again. There are some things that you can use that are a bit better, the C extension, on the developer. Those are C types, or even better, CFFI, another library, open source, I think is maintained by the same people who maintain PyPy. In fact, they work pretty well together. And basically, this makes your Python application able to call C code in a very, very, very nice way. And you might be surprised, but it's exactly what we use for our library, called PyAvro RS. Now, this is not the only way you have to have a better experience writing C code for Python. There is also Cython, kind of standard de facto in the industry, I must say. Cython is basically a compiler for Python, which gives you a superset of the Python language. And in Cython, you can access some of the internal structure that you can access with C extension, and you can do it in a way that gets compiled in C. Problem with Cython is that if you're targeting Python 2 and Python 3 and PyPy, which is experimental, if I remember, then you gotta write your code almost 3 times. Sometimes you can get away with less, but you may need to duplicate your code a lot. The library we are gonna run our benchmarks against, FastAvro, that implements Avro serialization as well, that uses this approach. Now, before we go into the code of our library, I would like to show you how to CFFI in Python. Now, let me stop you here. I have to comply with the safety regulation. So from now on, there will be a lot of code with pointers, unsafe, terrible memory management, duck typing. So if you don't feel like it because it's too morbid for your standards, just leave the room now. You stayed, it's on you. All right, so this is Python. It's very easy, as usual. So you import this library, CFFI, you open your header file, you just import it, then you also open the binary where the function definition is, and finally you call the function. That's it, right? I mean, there are also other more complex methods that are a bit better than this one, but this is the gist of it. So the magic here is the ABI. You may remember from the talk this morning, ABI is Application Binary Interface. So what this means is basically a convention. Well, I wish it was one. It is a way to name conventions that basically, they just standardize the way you put stuff on the stack, like input, output for your functions, how the functions names are mangled, stuff like that. So the ABI for C is kind of the lingua franca in any language, and so it is the same for Python. Now, the idea here is that we want to use the same ABI for C for Rust. And the way we do it is that we disguise Rust as it was a C application. So before we go into the details, let me explain to you why we decided to go for Rust instead of C. Well, this is a Rust conference, so I hope that everything I'm saying is pretty obvious. Rust, guaranteed memory safety, concurrency without data races, zero cost abstractions, modern syntax, awesome tooling, really awesome tooling, man, Cargo is fantastic. Like, it's really great. And also the community and all the tools and the language, like literally you have everything in Rust to be successful. So why not? Now, back to Flav on how to Avro.
Technical problems. All right, beginning of our journey to hopefully serialize data in Python using the Avro format is an Avro library. As we mentioned before, we wanted a Rust implementation of the Avro serialization format. So what we were looking for was a library or crate that was doing serialization and deserialization, hopefully, ideally compatible with the Serde framework, and as much as possible, that would follow the spec of the Avro format, which is way more complicated than it seems. So we did what any software engineer would do, open Google, Stack Overflow, GitHub. Nothing was solving all the issues. We also had a lot of free time. So again, like any software engineer with too much free time, we built our own. So this is Avro RS, which solves all the points that we mentioned just before. And it's open source, it's available to anyone. And this is the one that we're using in Rust. And as a user of the library, the only thing that you need to worry about, like if you want to serialize some data, like some test structures, is to implement the deserialize and the serialize, well, to add the primitives for Serde. And as a user, this is the only thing that you need to do to serialize this structure itself. Now, if you want to work with schemas, because Avro is nice with schemas, this is the way you do it. You give it a string, which is your schema, JSON formatted, and you call schema parse.str, and that works. Now, next, if you want to encode some data, create a writer with the schema and something that you can write into. Well, this is just an example with vectors. You can create some records in two different ways. One with just the struct. The other one is adding things to a hash map, and then at the end you're going to get serialized. You can append to your writer, and in the end you get some bytes that you can that are like Avro encoded. Now you've done the encoding on one side. Next would be decoding. So you create a reader from the bytes that you just got. And you can iterate over all of the records in the reader, and then you get the structures back. So that's pretty much it from the Rust side. Next one, back to Antonio to introduce you how to FFI.
All right. I'll try to be brief, so you don't need to look at my bad code a lot of time. First of all, when you write a foreign interface, you want to think about your data, so structs. There are basically, two ways of writing structs that can be used by a C interface. These two. So the first one, you just define your struct, basically with all the fields that you need. You may need to use some of the things that are either FFI or some other library, depends what you want to use. So for example, you can see those C_char, which is not usually what you use in Rust. Is also a pointer. You can see the star mut, but also, you need to be careful to basically tell the compiler, as I don't remember where the speaker is this morning, but someone said this morning, you basically, yeah, here we go. Someone say that you got to tell the compiler, hey, this is going to be accessible from C. Please don't be smart. The other way you can do it is basically just define this. This is called an opaque handler or an ADT, abstract data type, or whatever fancy name you want to use. So you're basically not giving access to the user to the internal fields of your struct, but still they're able to use it as a function argument or return type. Since I mentioned it, functions. So this is basically one function in our library. Don't be scared. So this is basically what the function does. So it is exactly the same function that Flav showed you before, schema parse string. It only needs to deal with the C types. So basically what it does is the reference in the pointer to the JSON. It then say, hey, this is a Rust reference, then it transforms it in a string. And for the return type, since we want this to outlive the function, we want to allocate it to the heap, so we use box. And then we cast it to the opaque handler, as I mentioned before. Finally, the signature of the function also changed. So first of all, this is unsafe code. And also you can see that we pass around pointers. Now, the magic happens here. This is a macro that we wrote. And basically, this is what makes this function really be understood by C. So let's explode it. After the macro gets exploded, this is what we get. We got a no mangle on top, which basically says to the Rust compiler, don't be smart, don't mangle the name. We say that the function is to be accessed from something external, C. And we also have this thing. So someone mentioned before in one of the questions, what happens when we have to unwind the stack because something happens? Well, this is what this utility does. We've been through many iterations of the utility. It's complicated. It's not easy. But unfortunately, there is no good way and no standard about stack unwinding. So what this does, basically, we want to be sure that in case there is any problem with our Rust code, we unwind the stack in Rust land before we give it back to the caller, or at least we try. So gotchas, many gotchas. So as I said, unwind and safety, that's a problem. Error codes, if you want your code to look like C, you got to define error codes, no results there. Explicit memory management. Remember, in C, you don't have the Rust syntax, so you gotta be very specific. Hey, don't free this thing. Hey, free this thing. Hey, don't free this thing twice. This kind of stuff. Enum duplication. So unfortunately, the story for enums is not great between C and Rust. So we basically have to duplicate all our enums, and we use a lot of enums in our C wrapper. So Rust wrapper that looks like C. Complex arguments. This is very important for our use case, and it will be a huge part of the talk going forward. But basically, it's like in C, you don't have access to maps, arrays, not even strings, man. Those are not strings, and stuff like that. So you gotta basically create your own and create your own way of communicating between Rust and C to use these complicated structures. And many more, trust me, like a lot more. And I'm sorry, there is no silver bullet for this, at this point in time. So the solution is Control-C, Control-V, go to our library and copy the utilities. This is the second project we do with the FFI layer in Rust. The third one, we'll probably extract everything into a library, but until then. Last thing, the header file. So, if you have written C, you know that you need an header file. Basically, it's a file where you need to rewrite all your structures and all the signatures of your functions using C code. And you gotta do it. There is no way around it. And you gotta use different types, sometimes very weird types. And you gotta make sure that it doesn't drift from your implementation. And trust me, we have another project that does this. You don't understand how many times I got this wrong. Like, you cannot even imagine. Well, there is a solution. Cbindgen. Cbindgen is awesome. It writes the header file for you. This is it. It's in our make file. You copy it. It works. It even transforms the comments you have, the doc strings in Rust, into comments. This is fantastic. No more drift. Nothing else. Use Cbindgen. Say with me. Cbindgen is awesome. Say with me. Great. I feel like in church now. Now, back to Flav on how to get up with Python.
All right. So last step towards our journey to get some Python and Avro together. How to use so we have the FFI layer that calls the Rust stuff. We may need like a Python wrapper to call the FFI stuff. So the way you do it is pretty simple, as Antonio introduced you a few minutes before. Let's say you want to like serialize some integer in Avro format. The way you do it is just, well, call your library with the correct function. If you want to serialize some complex types like lists, Python lists, this is a bit more complicated because, well, C doesn't have complex types. And so you need to create a new array for each of the elements in your list. You need to serialize it, append it to the array, and in the end you return the array. So it's a bit like writing C code in Python, and all of this is Python, which is important as well for performance. You just got to deal with it. Next is how you would serialize any type of Python object. So Python has like non-booleans, integers, and all of these have a representation in Avro. So the way we do it is just like depending on the type that we get from the object, we map it to a method to deserialize it, and then just like recursively go over it, and like it just works. And we'll return the pointer to the opac handler at the end for users in Python. So users, how would they use the library? Pretty much like the Rust library. They declare a new schema. They want to write data. We're using the schema. They can append stuff, get the bytes back, create a new reader, read all the data, and get the records back. So this is exactly this is the same interface between Rust and Python, which is good. Next, if you're building a library using CFFI, you may want to package it so that your users can use it pretty easily. The way you have to do it is make sure that your Rust code gets compiled every time you do changes to it. So you need to make sure that you recompile it every time you do changes to it. And you also need to package your Python package, for instance, as a wheel, so that you can. A wheel is pretty much like a package form of a Python module. And the way you can do this in Python is using setup.py files. Setup.py is, for those of you who don't know it, can be pretty much in cargo.toml with a bit more stuff and not as good, but that's just a Python way to do it. The important things in this slide is that you need to add additional data. You have your Python code that is going to get packaged, but also your Rust or C code. So you need to tell it, okay, well, I'm going to have this header file that's going to get included, the dynamic library, which is the Rust code that's going to get included, and this is not platform independent. You need to, if you're on Mac or Linux, it's different. And so, yeah, this is not great. You need to make sure. We had so many issues with this in the first project that we worked on. And so the solution to that, because there is a solution, it's called Milksnake. Milksnake is an open source project, and really it's awesome. It does all that I just said in the past 2 minutes, which 2 minutes to package something to a Rust audience is 2 minutes more, too much. So the way you do it using Milksnake, you just define one method that is going to be platform independent most of the time. You give it the command that you want it to run. So if your Rust is just cargo build, where your library is going to live and where the header file is going to get. And the setup.py just changes to be this with the task or the Milksnake task, and that's it. It works. It just works. To prove it, we just run it. Just build a package. It calls cargo build, and then you get all your things compiled. If you change the Rust code, it's going to get recompiled. If you don't change it, it won't get recompiled. So really, Milksnake is awesome. Now, onto the actual reason why we're here is was it faster? Why go through all of it?
All right. So we are all computer scientists, we are all engineers. Favorite part of our talk, numbers and charts. So this is a random benchmark. Not very random. It's actually pretty good for our library, but it doesn't matter. Basically, don't look at the numbers. They're just seconds on the y-axis, but it's okay. It's just a random benchmark. You don't know how it's made. So basically, you can see that we perform in some way on CPython, in some other ways on PyPy, changes compared to write and reads. Now I want to compare our library with FastAvro, which does exactly the same thing, but written in C. Here we go. Sometimes you're faster, sometimes you're slower. The important part is that they are comparable. If they are comparable, there is no reason why you should write C instead of Rust. That's it. You can write Rust. Tell to your coworker they are as fast as possible. Now, you want to know why we did this thing? You want to see how the actual official Avro implementation in pure Python compare against these two libraries? I'll change the scale. Here we go. Now, one thing to look at though, on the right-hand side, PyPy. Look at how fast the code is on PyPy. Man, it's not comparable, but it's not too far either. So once again, before you take out the big guns and you go into all these troubles of writing a Rust crate, well, maybe you have written that already, as we did, and then a C interface for it, which is a second crate, and then a Python library calling the second crate, maybe you should just use PyPy. Usually works, but in case you are in the 0.01% of the times, this is what I want to do. Now, before we go forward, I know this is unfair. I know these free libraries do something. No, not Avro. Avro no. I know the PyAvro RS and FastAvro do something more, which is also like munging and passing data around between Python and Rust. So not only the Avro encoding and decoding, but let's compare these free libraries against our pure Rust implementation of Avro. Come on. You can see it? I know you can see it. Okay, I'll change the scale only against our library. You can see it. There is a tiny red thingy there, maybe. You know, Rust is fast as hell. Now, if you were at EuroPython last year, this would have been the end of the talk. But Flav had more free time. So can we make it even faster on Python? Faster than Rust doesn't really make sense. Yes, we can. So you remember C extensions? Well, they have one good thing. You remember those complex arguments that I told you before? Maps, arrays, strings, these kind of things. Well, turns out that the majority of the time in the wrapper gets spent in just, going back and forth between these things. So what if we could write Rust extensions? Well, there is another library we built, PyO3 Avro Res. We are not that good at names. And it uses PyO3, which is a framework that has been already mentioned today. And Flav is going to show you how it works.
All right, so very quick introduction to PyO3. PyO3 is an open source framework to, as Antonio just mentioned, do Rust extensions. It uses the FFI to, that Antonio mentioned as well a few minutes ago, to expose C extensions to Rust code. And PyO3 in itself is very good, but it also comes with like a sister crate, which is called PyO3 pack, that will allow you to package your Rust crate seamlessly. Like literally, this is just, I love it. Yeah, so how would you do that? How would you use PyO3 to serialize Avro? So Avro RS is the Rust library. This is another library which would be the Python wrapper. You define a new structure and give it the directive that, well, this is a Python class. So a schema is going to be available to see Python code. Next, once you have a class, you may want to have some methods to it. So this is the way you would do it. Implementing a schema, and with the directive py method, it's going to say, well, everything that's going to come now are methods for the Python runtime. Constructor, just going to say, well, this is a constructor. It takes a string as input, and as you can notice, this is a Rust string, even though we're like interfaces with Python. PyO3 does the conversion for us, and we just need to deal with string over there. And what it does is basically just calling the parse string for the schema, which is the Rust code that we mentioned before, and then just initializing the object and returning the instance of the class. So pretty straightforward. They have very good documentation. Well, they have good documentation. Now that you have schemas, you may want to read or write data from using the schema. Reading data is can look a bit scary, but it's not that much. So this is the read method, still in the implementation of all the methods. We know that it takes some bytes as input and returns a Python object. PyO3 has some helper functions to let you convert like Python objects to Rust available like arrays for bytes, for instance. We want to read the data using the Rust implementation, and then in the end, once we have the Rust structure, we want to make it available to like as a Python object. So we have this method that is, well, two Python objects that will. What it will do is exactly like the one we're doing with the CFFI. Like depending on the value that we get, we generate the correct Python object. So if it's null, then we get a none. If it's an integer, then you can get an integer, etc. And same for lists. So if your item was an array serialized in Avro, then you can just create a new list, and for each of the elements in the list, you iterate over them, and then you encode them, and then you return the list. But the main difference with the first implementation is that this is Rust code. So this is, you don't have the back and forth between Rust and Python. This is all in Rust, and then in the end, Python gets the hand back. So Python, as a Python user, this is how it would look like. So pretty much the same. You can define a schema, have some records, write this record, encode it, decode it, etc. As I mentioned, the way to package it is using PyO3 pack is the way to go for it. There are other ways, but that one is the fastest one and the easiest one. You just have to remember PyO3 pack build, and then you get Python wheels, so package code already for you every time you just build your package. So yeah, like really PyO3 is awesome. Some gotchas, I mean, as usual. Currently only works on nightly, as mentioned earlier today. Uses some features that are not stable yet. So yeah, Python 3 supported only, but Python 2 is supposed to die in 6 months, so I guess it won't matter that much for so long. And the PyPy support is very new. Like I think it landed like a month or two ago, and we haven't managed to get our library to run on PyPy, but it needs some love, and it's promising. So yeah, was it even faster using PyO3 than all the other methods? Turns out that it was like at least an order of magnitude faster. As you can see, the new implementation is like the orange one at the bottom, and the main difference is just all the back and forth that were happening between Python and Rust don't happen anymore, because you just get your thing directly, and it makes a massive difference. All right, back to the next part of the presentation.
Next and last. So we promised in the title how to get away with it. So it's basically answering to two questions, at least in our opinion. First one, how to convince my colleagues that they should write Rust instead of C. Well, first of all, it's easy. It's hard enough to convince your colleague to write C already. So it's not that basically means you'll do it for them. So why not Rust? First reason is the most loved language on the Stack Overflow survey 2019 and 2018 and 2017 and 2016, maybe 2015 too, I don't remember. Anyway, everyone loves Rust. You know, you're here. Compilation just works. Cargo is amazing. Trust me, Cargo is amazing. It does cross-compilation. We use it for also Android applications, Swift applications, Python. It just works. It's fantastic. I've never seen a package manager that was that good in my life. Fast release cycle. Rust releases every 6 weeks, if I remember correctly, and you don't need to wait much to see your feature landing nightly, honestly. And it's a ton of fun. Otherwise, we wouldn't be here. Second question, which is probably the most important, how to convince my company. You know, they kind of pay the bills. So first of all, if you're working with Python, wheels, compile once, install everywhere. Well, kinda, better architecture. But you can create the compiled object, let's call it that way, it's a wheel, it's a thing, in Docker, and then install it somewhere else without needing the Rust toolchain in your production environment. That's pretty sweet. FFI interoperability. So if you go for the first approach, your code can be called very, very easily from Java, Objective-C, C++, Swift, anything that supports an ABI. And that's pretty cool and very valuable if your company does, you know, a lot of languages, because it just happens. Third, Rust is as fast as C, which means it's cheap to run. Rust is safer than C, which means it's cheap to maintain, and is used in production by a lot of companies. Yelp, ours, Mozilla, Dropbox, Google, Cloudflare, Facebook, you name it. Your company should be there too. Now, takeaways, what to bring home? Well, few things. Write Rust instead of C. How many times did we say it? Okay. Cbindgen is awesome. Cbindgen is awesome. Milksnake is awesome. It's pretty great. PyO3 is also pretty fantastic. And these are the links. So you'll find all our libraries, the open source software we mentioned, and that is the link to the slides in case you weren't able to take pictures. End of the show, people.
Anybody has any question?
Cool stuff. So you asked the important question, how to convince your C colleagues. Now the question is, how do you convince your Python colleagues that they need to write Rust? It's more difficult.
I guess the main selling point would be to show them the benchmarks. Even like, and Python colleagues, like even, so there are two ways to see this. Sorry? Okay, there are two ways to say it. Like if there are just Python developers that don't need to interact with the code, you just show them the interface, and it's exactly the same interface for Python developers. Now, if they have to interact with the Rust thing, basically everything that Antonio mentioned all the cool stuff for us, like safety and speed, like the benchmarks are sufficient. Community, documentation, well, just all the basic stuff.
All the nice things.
Any other?
So yeah, our library uses Serday, and we have some issues with the way we use it. So if anybody here is a like Serday expert or knows about Serday, we're happy to pay like coffee or beer to talk to you.